All right, so we're going to make a motor, and it's similar to the one that we use in our hairdryer. Much simpler, but similar principles are involved. So we're going to take a scrap block of wood, and we're going to mark the corners line to line, and we're going to just do that so we can find the center of the block, and that'll just give us a reference point. We've got some copper coil here. This is magnet wire, and that's the same type of wire that's used inside of our motor. We're going to use that to make our field windings, and then we're also going to use some permanent magnets. So we need to find a place that we can mount all of these different things, and we need to determine how we're going to set the magnets up. So we're going to make sure that the magnets are oriented so that their poles are opposing one another. And then also have two washers here. We're going to use those washers as bearings, and I think we're going to make our field windings about the size of that cap. Now be careful, the magnets will snap together. So now we're just positioning all our parts that we're going to need and trying to figure out where they'll go and how close they'll need to be together. Of course, the cap is what we're going to make our winding around, so the washers that are going to support the winding need to be pretty close to the cap, and the permanent magnets also need to be pretty close. So we're just making our marks here so that we can position everything, and it's pretty important that things are lined up fairly accurately, otherwise the winding may not turn smoothly. So we determine that we're going to measure off of the center point and about an inch away from the center of the square. So now that we have our intersection points marked, we're going to go ahead and drill our holes. We've taped the drill about a ½ inch up, so we want the hole to go in about a ½ inch. And we're using a 3/16 inch bit on the sides, and then we'll use a 1/8 inch bit for our for the other sides, and the other sides are going to hold our bearings. So these are the bearing screws, and we just happen to have some extra scrap screws, so that's what these screws are for. These actually came from an IKEA bed, and then these are just some scrap screws that we had laying around. You can use any screws or nails. What's important is that the screws are lined up right and that they're the same level. So that'll improve the efficiency of our motor. So we're just checking the level and making sure everything's lined up correctly. And then we're going to take some hot glue and get our permanent magnets, make sure that they are oriented so that they are attracted to one another. So we want their opposite poles facing one another. And so we just put some hot glue on the screw and then set the magnet in there. And the main reason we did it this way is that it's really easy to change the position of the magnets if we need to, and we may need to do that. So we've got a washer here, and again we're just hot gluing that washer right in place in a vertical orientation. And the hot glue allows for easy adjustments. And so now we're going to take our bottle cap that we had talked about earlier. We're going to wrap our field coil around it. We're going to go around it 7 times. And then once we've got the coil a fairly good length, we have about 3 inches of wire on either side. We'll loop the wire through and tie it off so that it stays in a consistent loop. There we go. And then we'll do the other side as well. We'll just loop the wire through, and that just kind of holds the loop together and gives us something to connect with our washers. All right, now we're just going to tape the edges of the wire to keep it together. And we're just using electrical tape. You can really use any kind of tape that you happen to have. Again, this wire is insulated, even though it doesn't look like it is. It has a thin lacquer coating on it. And so what we need to do now in order to allow power to flow through the wire and to get it to behave like an electromagnet is we need to scrape off the lacquer coating on one side. And notice how I'm rotating the coil. That's important. If you just have a thin strip scraped off, it may not be enough. So you really want to make sure the entire backside of the wire is completely scraped clean of the insulation. And you can feel the difference once the insulation is completely gone. It's a little rougher than when it's still there. So now we found out that the magnet was a little too close, and so we were able to take it off with the hot glue, just pop it off, and then reposition it. Okay, so we're just making some fine-tuning adjustments with our field there. And what's happening is the power flows from the battery through the washer into the coil and creates an electromagnet. On one side of the coil, it pushes against the North Pole magnet. On the other side, it pushes against the South Pole magnet. Then it causes the coil to flip over, before it does that, the electricity flows out of the other end of the coil back to the batteries, and then the coil flips over, and then the process repeats. And so what's happening is that the coil's functioning like an electromagnet, pushing against our permanent magnets and rotating again and again. Now this coil is just one loop. The motor in our hairdryer had 5 loops, and so it was called a 5-pole motor. So now we're going to see if we can use this motor to do some work. So we're going to take our washer here, and we're going to just mark out some circles in paper, and we'll take some scissors, and we're going to cut those circles out. We're going to make a little tiny fan out of this paper. Now the motor that we made isn't super powerful, so we have to make a pretty light and small fan, but it does move and demonstrate the principle. So we're just twisting each of the vanes on the fan so that they are, each of the blades I should say on the fan, so that they look more like a real fan. And we're going to push that through the end of our coil. We'll just put a little bit of hot glue on that to hold it in place. And then we'll give it a whirl and see if we can get the motor to actually spin and do some work for us. And there it goes. So some interesting experiments you might want to try are what happens when you take one of the magnets away. If you have the 2 on either side, what happens when you take one away? What happens when you rotate the magnets around and they're not opposite poles facing, but they're similar poles facing? If you have enough magnet wire, you might want to try scraping all of the magnet wire clean and seeing what happens, or scraping none of it and seeing what happens. And does it still turn? Why not? You may also want to take a look at maybe doing multiple windings and seeing if that changes the performance of the motor. Hope you've enjoyed it.